All right, everyone, welcome to Comparing Rates of Change. So, some of this should be a review. We have talked about rates of change already this year, but I still want to specifically discuss how to compare them and why we might compare them. So, to find a rate of change, because to be able to compare them, I need to know what it is, in a table or a pair of points, what I am going to do is I am going to find the difference between y values and find the difference between x values. And then I'm going to put the change in y, this means change, over the change in x, and simplify. To find the rate of change in an equation, we are going to focus specifically on linear equations. So I'm going to use that format y equals mx plus b, all right, where y is on its own. Y needs to be isolated for this to work. So if it's not, make sure you get y by itself, okay? And then I am simply going to look at m because that is my slope or my rate of change. Note that note that m is with x. It's whatever x is being multiplied by. So if it's not being multiplied by anything, so to speak, like there's nothing with it, then we would consider the slope to be 1. If there is no x value, then the slope is 0. Okay, so if x does not appear in your equation, that means your slope is 0. If there's no y value in your equation, that means there is no slope because it is a vertical line, but you will not see anything like that in these particular situations where you're comparing slope. And we'll talk more about those situations in another video. In graphs, we are going to look at rise over run. So we look at how the y changes again over how x changes. But really what we're doing is we're looking at how the graph moves from left to right. Does it go up or down? If it goes up, it's positive. If it goes down, it's negative. And then we look at how it moves from left to right as well for our run component. Okay, so this is how much it moves up or down, and this is how much it moves right when we do that. So, an example, we have a table, okay, and we're going to see that 13 to 17, we're going to look at how y changes, right? And in this case, it changes by adding 4 each time. Okay, we add 4, add 4, add 4. Now be careful, sometimes you'll have different rates of change, or it will look like it's a different rate of change in between each one. It doesn't mean it is different. You might notice that it's also different on the x side as well. So just see, you should end up with the same reduced or simplified rate of change each time if this is linear. So we have plus 4 over here, we have plus 2 for each one over here. So I put change in y. Oops, sorry about that. Change in y over change in x. So y changes by plus 4. X changes by plus 2. So that means we have a rate of change of 2. Here we have an equation. It is in slope-intercept form where y equals mx plus b. X plus b. And we look at whatever is with x. So I see here that this is negative 4/3 with x. So that is my slope. It's whatever is being multiplied by x. All right, now I have a set of points here. We're going to look at how we change from x to x and y to y. I like to put points into a table to do this. You don't have to put it in table format, but it does help to organize your thoughts, or it can help. So definitely recommend it if you struggle to see how they relate to each other. So from -3 to +1, I have plus 4. From 9 to 12, I have, oops, not 4 again. I have plus 3. And so I don't know what just happened there. Plus 3. So I end up with positive 4 over 3 as my slope or my rate of change. All right, finally I have a graph. So I'm going to look at one point to the next, but really what I'm looking for is where I cross over a coordinate. So I could use that point there, this one here, this one here. anytime you're looking, so I can't use this because it doesn't sit on that place where the coordinate crosses, okay? So I don't want to use that one because it's just not going to be very helpful to me. But if you don't have coordinates already explicitly labeled on there like I do with these dots, then just look for where we cross over that coordinate line, okay? So in this case, I'm always going to go left to right to count this up. And I am moving down if I go from left to right. So my rise or my run. So my rise is down 1, 2, 3, 4. And since I'm moving in a downward direction, I have a -4. And then I'm going to look left to right. So from this point here, I move 1, 2, 3, 4, 5. And that's always going to be positive on the bottom if I'm moving left to right, because that's moving in a positive direction on my x-axis. So -4/5 there. Okay. My U-try, I do want to point out that the one that is largest out of all of the 4 example that I just did, I'm going to look at those numbers. So those numbers include 2, 4/3, -4/3, and -4/5. So if I was putting these in order from least to greatest, I would have to simplify 4/3 into the approximately 1 2/3 that we are dealing with there, okay? And 4/5 is less than 1, so, and it's negative, so that kind of changes it as well. So the largest is that 2, and the smallest would be -4/3. So I can put them in order. We have 2, 4/3, of course, because it's still positive, -4/5, and -4/3. Depending on what you're being asked for, you may need the largest, you may need the smallest, you may need to put all of them in order. So be prepared to remember our rational number and real number ordering to set those all up. All right, now for the U-try, I want you to please, on your paper, find the rate of change for each one of these. So you should have 4 rates of change on your paper. And then answer the question, which function has the greatest rate of change? So each one of these, I want you to please find the rate of change and then identify which one has the greatest rate of change, A, B, C, or D out of those options. Good luck, have fun.